Hello everyone. I'm Sakshi Aggarwal and I'm working as an application developer with ThoughtWorks. Let's get started. So, of course, thanks to Prerna and Shagun, now we know what GraphQL is. So let's move ahead and see how can we implement GraphQL within our project. So so traditionally, we have two approaches, two ways we can implement GraphQL within our project. So the first one is known as schema first approach, and the other one is called code first approach. So as the name suggests, schema first, we give priority to our schema. That is, we define first and foremost, we define our schemas, and then we move ahead and define our resolvers. Whereas in code first approach, we define our resolvers first and then we generate our schemas programmatically through them. But before diving deep into these strategies, let's just take a step back and recap schema a bit. So as Shagun covered, schema is basically the set of rules that are available to client. So it manages our queries and mutations. It also provides us the possible set of data which is available to client, which includes objects. It also validates our query and executes it and returns the corresponding data set. So basic building blocks for our schema consist of basically types. So types could be object types, scalar types, enum types. Then we have type modifiers, which includes list and non-null. And then we have fields. Since Shagun has already talked about them, so we are not going into details. But if you have any queries related to them, so you can write them in the Q&A section and we'll be happy to answer. So moving ahead, what is schema first approach? So as I told you earlier, so we basically give priority to our schema in this approach. So first we define our schemas, then we define our resolvers, and finally we execute our queries. So the first step within schema first approach would be schema definition. So here we define our schemas within schema definition language. So a typical schema looks something like this. Here we have a query, a type query. So we can have either a query or mutation depending on our use case. But for demonstration purposes, we are using query here. So within query, we have an operation called get user details, which accepts an ID and it returns user details object. Here we can see user details. It comprises of ID, name, and email, which are of scalar type. And then we have another type field called address, which in turn comprises of address, one, street, and city. So this is how a schema looks like. Now we have our schema. So we'll move ahead and implement our schema using resolvers. So this is how a typical resolver looks like. So herein we have a query node. So within that we have operation. If you would look closely, observe closely, so we can see that this operation name is similar to what we have defined within our schema. So, so this operation, this function basically accepts ID within this args argument. So we assess this using args.id. So this takes this ID and searches its database and then returns the data and binds it into user details object. So this is how this resolver works. Now, since we have our schema and as well as our resolver in place, so the third and final step would be the execution of the query. So once we have our services up and running, so the GraphQL, so in this we'll just it validates our query, and then it returns the corresponding data set. So this is how we execute our query. So this is our query, and this is the corresponding data that is returned to the this query. So if we look closely, we'll see that this data matches our query. Uh, this is exactly the power that GraphQL provides us. That client can ask for exactly that data which we want to access. So these are the steps that we have followed within the schema first approach. The first and foremost being the schema definition in SDL format. Then we implement the schema using resolvers. And finally, we execute the query. Now, these are some of the benefits that schema first approach provides us. So since it is in the similar way that we do our test-driven development, so as developers, we need to think about all the possible scenarios and user conveniences before designing the schema. So this results in better designed APIs. It is more abstract and less dependent, as it uses dependency inversion principle. So, and lastly, it promotes faster development, as it lets front-end and back-end developers to work independently each other using mocked schemas, which are easily achievable using third-party tools like GraphQL editor and GraphQL tools. So it has its own share of cons as well. So as our project size increases, it is very difficult to keep schema and resolvers in sync. And this leads to serious inconsistency problems. The second thing is, since it is difficult to reuse schemas written in SDL, so it leads to code redundancy, which again defies our clean code practices. And third is, it is difficult to work with distributed schemas, but we can overcome this using third-party tools. So yeah, so these are some of the tools that that would ease out our development within schema first approach. So there's Apollo server that could be used with JavaScript or TypeScript. Then we have GraphQL tools, which could be integrated in JavaScript, and then we have GraphQL editor. So yeah, that was it that I had. So let me hand it over to Abhishek, and he would take you through code first approach.
Thank you, Sakshi. Let me just share my screen. I hope my screen is visible. Okay, let's start. So we saw like the schema first approach, and Sakshi explained very well, like how can we start writing our GraphQL with the schema first approach. Now we can see, like in the last slide, we discussed about the problems that schema first had. And so these are the different problems. First one is the inconsistency. What does it mean? So we saw like there is a schema, which is nothing like a string, and then we have to define the resolvers for that schema. Now to map the resolvers with the schema, which is in a string, there we need the consistency, and for that we will have to manually look at that. Okay, the schema is this. Now if we have written the correct resolvers for them or not. So there can be the cases where we might feel the inconsistencies between the schema and the resolvers. This is the first problem that it can have. Second is the modularization. Now think about this situation where your code base is really big and it is growing slowly. Now, if you look at the schema, that will also grow up automatically, right? Now, in that case, you would want that your schema should be break down into smaller pieces, or it should be modularized in some way. So then in case of the bigger projects, there you will face the problem of modularization. There will be only a single schema, which will again be a string. The third part, in any way, if you are able to modularize your schema, or if you have multiple projects, but you want a single API endpoint, which will return data for your queries. For that case, you will compose uh, a single schema from the different small schemas, and you will build a same single schema so that you can get every data from that single endpoint. In that case, you would be needing composition. Now we have these problems that we have discussed, but there are solutions already present in the market. For inconsistency, we have GraphQL code generator. For modularization, we have GraphQL modules. And for the composition, we have GraphQL tools. So we discussed about the problems in a schema first approach. We also discussed about the solution. Then there is a question, then why do we need code first? If everything is achievable by schema first, then why do we go for the code first? Okay, so for the first one is tools are there, but there is a learning curve. Like we discussed 3 tools for now. There can be more, but with every tool, there will be a learning curve. Second point is duplicate type or fields in case of schema first. So we discussed like there will be a schema which is in string, and there will be resolvers which should be exactly equal to this, which should exactly match to the schema. For that case, there will be duplication between the types and the fields that we have defined in case of schema and resolvers. For example, if you see these 2 screens, left hand side we have the schema, right hand side we have the resolvers, and if you see, there are different, like author, there is author type, there is post type, and this is the duplication that we see in both the screens, schema and the resolvers. And we all know that duplication is not a good coding practice, so we try to remove all the duplications that we have in the code. The third thing would be, for an existing code base, we will have to write schema for each API. Now think about this solution, this situation where you have an existing code base. Now on top of that, you want to integrate GraphQL. Now if we go with this schema first approach, we will have to write the schema for all the endpoints or for all the APIs that we have, and that will be a lengthy process. In that scenario, we cannot use, or we cannot go with the schema first approach. In that case, we would be using the code first approach. Now it is not about what is good or what is bad. It is about when to use what. Now, if we see like the code first approach, in code first approach, we write the resolvers and the schema together programmatically. Like in schema first approach, we talked about like we first write the schema, and for that we should know everything beforehand. Like these are the types, these will be the fields. We should know everything beforehand. But in case of code first, you will be writing the schema and the resolvers together. Now you know, like, okay, so this is the schema and this is the data that I have to return. You're writing both things together. And finally, when you're ready, like you're ready with the code, okay, this is the thing that I have to deliver. After that, you can finally create the schema out of it, which you can use as a API documentation, which you can use, which you can give to another, like your friends or your colleagues, as a API documentation, which you can share. So if we see the code first approach, this is how the code looks like, where we defined the schema using new GraphQL schema, and then we define the query and the name of the query, and then fields, and finally we define the resolver, what it will be returning. Now There are different tools for the code first approach. First one is GraphQL.js, which is implemented in JavaScript. Second one is Nexus, GraphQL Nexus, that is also for JavaScript. And the third one is GraphQL SPQR, that is built in Java. Now, so we discussed about schema, we discussed about resolvers, queries, these all things. Now, how do we handle the errors? So think about this query where we are asking for links and the description, and also we are asking for the address. In this, uh, and let's say address is not present, like your schema is not returning address, it just returns the description. In that case, when you hit play button, then you will get this kind of uh, response where you will get the data, which is of course null because there is some error. And you also get errors field, which is an array, and in that array you will see that okay, there is field undefined error and field address is undefined. So this is the kind of error that you will get if you run this query and if address field is not present. And there is if you see the response code or the status code of this query, this will be 200 okay, which means for every error that occurs, the status code will be 200, but we need to go through the response body and see if data is null or if data is there and error is not there. Like from errors array, you will see, okay, error is there or not. And in one case, for example, in this case, there can be some scenarios where there is partial data, which means you asked for name, address, and one API returns you the information and second API doesn't return you the information. There is some issue in the second API, and your GraphQL server was aggregating these both APIs and returning you the full data. And now because one API is not working or one service is not working, you will be getting only partial data from one service. So at that time, this is the kind of response you will be getting. Like, okay, so for one user or for one user's name Akshay, the address is there, but for the user second, the address was null. So you're getting both the things. You're getting data as well as the error. And this is what we call as partial um, data in GraphQL. So we'll go through the code for this one in the next session. Yeah. So we have a break time for I think 5 minutes, and after that we'll be starting the code review session. And there you will be seeing like how to integrate the GraphQL in your code. Thank you.